Without further delay, I'd like to introduce Dale Boucher, who's going to be talking about volatile rich ore. So, Dale.
Well, thanks for getting the name right. Boucher is a good French name, and of course in Canada we understand how to say it, but when I travel around the world, I get all sorts of versions of that. Okay, so my question was, what constitutes a volatile rich ore? And I think in order to understand that, we have to understand that it involves a mining activity of some kind. So when we look at mining, there's this thing called a mining cycle, and this is pretty typical of most mining operations. Every mine has their own cycle. This is kind of generic in form. It always starts out with exploration, moves into a mining activity. There's some kind of processing or refining. You end up with a product. You end up with some kind of mine closure or rehabilitation process. When we take that particular type of cycle and apply it to space mining, we end up with something a little bit different. There's still similarities. We end up with a remote surveying operation, resource prospecting, definition, extraction mining, a beneficiation, processing, a product. And what becomes important with space mining is the waste cycle. So waste cycle is actually becomes a product feed for another type of ISRU activity. And so we have to be cognizant of this as we go into space and start looking at mining in space. If we take that concept one step further, I keep using the wrong arrows here. If we keep using that and take that one step further, what we find is this whole cloud of activity kind of in the middle, that beige-looking stuff called site preparation, maintenance, and repair. Terrestrially, when we look at mining operations, we take for granted that there is oxygen available, that there is some form of water or processing material, that labor is going to be relatively accessible. But when we start looking at mining off-planet, that whole paradigm changes, and we have to start considering that as we start looking off-planet. So the question to try and understand what really constitutes a volatile rich ore, you first have to define what it is that you're trying to mine. You need to define the commodity of interest. What are you after? Are you after gold? What I put up here is just one of the many forms that gold can take terrestrially. Are you after gold? Are you after water? You're looking for what kind of water? Is it hydrated minerals? Is it concentrated as granular material? Is it amorphous, crystalline, unobtainium? Are there other volatiles that you're interested in, perhaps helium-3? The key point here, the key takeaway from this slide is there has to be a definition of what is marketable or useful. And those are not necessarily the same thing. If it's useful to sustain a robotic mission or human life, it might be totally different than something that is actually marketable in space. The big paradigm here is, to quote a friend of mine, what goes on is what's mined in space needs to stay in space. That makes the most economic sense from an investor's point of view. You don't want to have these long logistic trains trying to get your product from the mine site on some asteroid back to Earth and landing it so it becomes actually useful and becomes a marketable commodity. So I've got a couple of slides here on milk stations. Everybody sees this, so I'm not going to belabor this at all, but what's interesting about this slide and the following slide is it presents a great elemental analysis of what L. Cross observed. And for a miner, that's great stuff. But what it doesn't talk about is some of the other aspects, some of the very critical aspects that need to be understood in order to understand, in order to determine that there is volatile richness. In other words, can a particular element or a particular volatile be mined in a useful fashion? So a little bit of prospecting 101. Some of you have probably seen this and probably know more about it than I do, but prospecting is really exploration. It's conducted in a very stepwise fashion. It's staged. You start with some kind of geological reconnaissance, surface geochemical sampling. You can think of L-Cross and LRO as being that kind of first early stage of surveying. It's generally followed with some kind of sampling activity. And with a very small number of exploratory samples, usually in the form of drill samples, drill cores. Select targets. We're going to choose kind of the where we want to go and how many holes we're going to drill. To ground truth the reconnaissance stage data. And what we're really trying to do is trying to say, yeah, that, you know, our remote sensing has really has some truth, some validity to it, and see the cores that this is really what we're finding. So you can think of the Resolve project as perhaps being the ground truthing in the exploratory phase. After that, you can move on to a more extensive, closely spaced drilling activity. What you're trying to do there is you're trying to provide a three-dimensional pose and position estimate of the particular ore body that you're looking at. If that shows good results, then you might move to a reserve drilling to try and provide a final assessment and a total estimate of the actual deposit before the mining begins. During the mining operation, there will also be a large amount of sampling that will take place, so that you can further define and improve your models of that particular ore body, and in fact, most of new ore deposits, at least in around the Sudbury impact crater where we are found by this type of drilling. They find suddenly a nice pocket of ore that was totally unrevealed in earlier definitions. So the prospecting starts with, you know, the exploration stage. You start with some kind of surface bedrock mapping. You sample, you identify the map outcrops. You might use geochemical methods to you know, kind of the old prospector out in the backcountry chipping away at an ore body or at an outcrop. And what you do is you begin to take this kind of data and you compare it to values and models of known ore deposits, largely because prospecting is still a black art. And you'll see as I go on what I mean by that. The value of an ore body is really determined by two things. One is tonnage and the other one is grade. Tonnage really is an estimate of the volume, and this is where it starts getting into black art. The grade is an estimate of the concentration or the value of the commodity that you're chasing. So the tonnage is done by simple sample drilling and position, knowing the position of the sample, you know, the actual location of the sample, where did it originate, how pristine is your sample. Use geometric models to smooth some of the edges and create some kind of definition of this three-dimensional object called an ore body. The grade is really an average concentration. You have to be very cognizant that the grade can vary from one sample to the next and can vary right across the entire ore body itself. So here's some couple of cross sections. What you see, the big red and kind of, or sorry, blue and pinkish colored unit is a cross section of a number of drill holes used to try and define an ore body. The results can be interpreted in two different ways, as you see with these two cartoons on the right-hand side. I don't know if you can see my cursor here, but interpreted ore zones can show two different things. The same drill data can be represented in two different ways, and this is where it starts getting a little bit spooky and a little bit black artish. So when you get into development drilling now, remember we just looked at exploratory drilling. When you get into development sampling, what you're really getting into is a very close spaced drilling. The average underground kind of ore body sheet formation up around Sudbury requires spacing in about a 50-meter grid. So every 50 meters, we're drilling a new hole that goes down 1,000 meters. And looking at those samples and trying to pull them up and determine, you know, whether it's valid as a mining operation. So it's very extensive, it's very costly, and it's very time consuming. There's also a feasibility stage where you do the final determination just before you actually begin mining to say, yeah, we think that all of the kind of stuff that we predicted is actually there. So you know, let's go ahead and build a mine. So we want to end up with this holy grail. And this is an ore body that was developed using that type of close-in prospecting drilling. And this is something very similar. I'm just going to skip over that because I see I'm running out of time here. So what we want to do now is we want to get into looking at how to mine the activity. And what we end up doing is begin to start weighting various activities to do the actual mining. So we've determined there's an ore body there. Now, how do we want to mine it, or is it even worthwhile mining?
Dale, you have 90 seconds.
Thank you very much, and I'm almost done. So what you'll see is various categories that relate to things like surface, slope, topography, infrastructure, where's the labor, that kind of thing. And from that, you can determine your mining method. Things that you cannot change, for example, are things like the mining ratio, which is really how much waste you have to remove in order to get at the volatile material that you're chasing. And so, just to wrap this all up, what constitutes a volatile rich ore? Darn good question. You've got to define the volatile. You have to, you know, is it mineable? Can you hold it as a volatile, or is it a great escape artist like hydrogen might be? Can you establish a minimum grade? What's the bare minimum that I can tolerate based on my economics or my process? Can I accept impurities? Is mercury okay? What about chlorine, sulfide, that kind of thing? I need to establish a minimum accessibility criteria, and this is where it becomes important. Is it close to surface, or is it deep? And remember that for planetary mining, deep is anything more than 2 meters below surface, because we just haven't done anything like this. Really shadowed zones, that's going to present some problem. Is there a vertical cliff descent required to get into this ore body? Are the rubble fields available? Establishing the mining operating conditions. We need landing zones, we need power, we need logistics, we need maintenance systems, we need shipping, and finally, you know, what about the economic feasibility? Is there a net benefit? Can we really realize a net benefit by doing this operation? Finally, when we go into the final trade, we have to trade space on more than one site. And to quote a great geologist at INCO up here, we may as well give this site up as a lost cause and try again, because our success rate is something like 50%. And so that is it.
Great, thank you very much. Great talk, Dale. I'm thinking that this is kind of the U in ISRU. We've been talking about the in situ resources. But you're starting to hit on whether or not they can be utilized, and prospecting, of course, is that first step. So thanks for a great talk. One of the things I want to mention while people are typing questions is that we have done a field training up at Sudbury Crater that NLSI has with our Canadian partner, and so this is a very interesting location that you're in. So we have a couple of questions here from Arlen Kratz. First of all, typically what fraction of the cost in exploiting a deposit is involved in defining its value?
So a well-known trade secret is that the average cost at okay, so the average cost on doing a mine evaluation is about $50 million. And they are right about 50% of the time. And so that means that 50% of the time they blow $50 million down the tubes and say, well, there's nothing here worth mining, let's go.
Okay, and maybe it'll be higher when we go to the moon. Michael I has the question, one would hope that the rehabilitation starts in parallel with the exploration phase and be executed in parallel with the mining phase, and not only after product realization, to avoid mistakes done at home. So I don't know if that's a question, but if you want to comment on that at all?
Yeah, very quickly, we need to be cognizant of the fact that the mining that probably will take place here is not going to be in large open scars. I think Jerry Sanders could probably speak more to this than I could, but I know that during the Constellation mission activity, there was an exercise that showed that in order to support the Constellation mission at the South Pole, including life support and ascent fuel, to produce enough oxygen using the hydrogen reduction of ilmenite, which is a 3% efficient process, would need to excavate a soccer field size area of regolith about 10 centimeters deep per year.
Yeah, so it's not significant.
I think it's a good point to bring up. I think we have to be cognizant of that whole activity. The rehabilitation really is about taking things like, for example, if you're running the oxygen production plant using hydrogen reduction, you have a heated regolith. Well, that heated regolith itself can be used as a feed stage to another process, perhaps making lunar bricks. And I think we need to be cognizant of that as we go ahead.
Okay, we have time for one or perhaps two more questions. The next one is from Pam Clark at Goddard. Dale, could you comment on in-situ measurement reconnaissance options before committing mining resources? What kind of instrumentation?
Well, that depends on what you're looking for. Again, you need to do the definition. If you're looking for water ice, Resolve has a great suite of technologies built into it. They've got a neutron spectrometer and a near-infrared spectrometer that are all chasing water signatures. And so if that's the volatile that we're interested in, certainly that's what we would expect to use to some kind of remote sensing before actually putting a drill in the ground and using mission time and energy to pull up a sample. Can we do this remotely? Sure. The L-Cross data was significant. Alan Binder's prospector mission was very significant in terms of the hydroxyl signatures. Again, you really need to think carefully about what you're trying to chase. If you're chasing platinum groups or gold, then you know that your instrumentation suite would become a little bit different.
Okay, great. And then one last question.